Hi everybody, today we'll be looking at hypothesis testing with two populations with an unknown standard deviation. We'll do full hypothesis testing and then we'll use Minitab to do the test statistic, the degrees of freedom, and the p-value. When doing the hypothesis testing for two populations with unknown standard deviations, it's important that our two independent samples are randomly selected. It's okay to have a small sample as long as the samples come from populations that are known to be normal. Normality of larger populations is not required. Samples are not required to have the same size. Tests can be done with either sample data or just summarized data. Our first example says an engineer is comparing the weight consistency of metal brackets produced at Factory A and Factory B. The goal is to determine whether there is a significant difference in the average weight of brackets made at the two facilities. Random samples were taken from each factory. The below weights are given in grams. In Factory A, the weights were 52.3, 50.1, 51.7, 49.8, 50.5, 51.1, 50.4, and 52. Factory B had weights of 48.9, 49.2, 47.8, 48.5, 47.9, 48.7, 49.3, and 48.2. Assume the weights are approximately normally distributed, and we don't know the standard deviation of the population. We also don't assume that the two samples have the same standard deviation for their population. At the 0.05 significance level, is there evidence that the average weight of brackets differs between the two factories? Before we get started, let's point out that we have to do a t-test because we don't know the standard deviation of the population. It's important that you always pick the right test when you get to Minitab. Our null hypothesis is that the means of the two factories are equal, so mu of A is equal to mu of B. This also means that mu of A minus mu of B would be equal to 0. The alternative hypothesis is that mu of A is not equal to mu of B. That means mu of A minus mu of B is not equal to 0. Let's take our data over to Minitab to find our test statistic and our p-value. I entered my data in column 1 and column 2. I labeled it Factory A and Factory B. Now I'll hit Stat, Basic Statistics, to Sample t-test. On the drop-down menu, I want to say each sample is in its own column. I'll put Factory A as sample 1. I'll put Factory B as sample 2. On the options, for the confidence level, we want 95 because we are given 0.05 as our alpha. Our hypothesized difference is 0, and our alternative hypothesis is that they are not equal. The summary gives us the mean, standard deviation, and standard error of the mean for each of our samples, Factory A and Factory B. We have a t-value of 6.30 and a p-value of 0.000. If you wanted to see more decimal places, you could, as always, go to the table options and pick a much larger value. Now we can see p is 0.000058, which is much less than our alpha of 0.05. Because p is less than alpha, we can reject the null hypothesis. There is sufficient evidence to conclude that the mean weights differ based on the factory they were produced by. Let's look at a second example. An urban transportation researcher is comparing the average battery life in hours of electric scooters from two different manufacturers. Because the scooters are built using different battery types, the variability in their performance may differ. The following summary statistics were collected from independent random samples. For brand A, the sample size N1 was 12. The sample mean, x1 bar, is 18.6, and the sample standard deviation, S1, is 1.9. For brand B, the sample size N2 is 16, the sample mean, x2 bar, is 17.1, and the sample standard deviation is 1.5. Assume the battery life is approximately normally distributed for both brands. At the 0.01 significance level, is there evidence that brand A scooters last longer on average than brand B? Our null hypothesis is that the means are equal. mu1 will be equal to mu2. Again, mu1 minus mu2 would be equal to 0. The alternative hypothesis is mu1 is greater than mu2. We're saying that brand A lasts longer than brand B. This says mu1 minus mu2 would be positive or greater than 0. Let's take our summarized data and go over to Minitab. Because we have summarized data, I'm going to start by going to Stat, Basic Statistics, and to Sample t-test. I'm going to select that we have summarized data, which gives us a place to enter our sample size, mean, and standard deviation. Our first sample had 12 elements with a mean of 18.6. The standard deviation was 1.9. Then sample 2 had 16 elements with a mean of 17.1 and a standard deviation of 1.5. Notice in this case, our sample sizes are different, which is okay. Minitab will calculate the degrees of freedom based on all of the other information we've entered. Now we can go to the options, and we want to change our confidence level. We were given an alpha of 0.01, so that means our confidence level is 99. We want to keep the hypothesized difference of 0, but we want to go to the difference is greater than the hypothesized difference for doing a right-tail test. Scrolling down, we can see we have a t-value of 2.26 and a p-value of 0.018. This p-value is close to our confidence level of 0.01, but it is not less than the 0.01. Because our p is greater than alpha, we do not reject the null hypothesis. There is not sufficient evidence to conclude that brand A scooters last longer on average than brand B.